You are currently looking at a view of the Space Telescope Operations Control Center, also known as the STOC, located at NASA's Goddard Space Flight Center in Greenbelt, Maryland. The astronauts aboard Space Shuttle Atlantis, along with ground teams of flight controllers at Johnson Space Center in Houston and here at Goddard, had a challenging but ultimately very satisfying day as the two main objectives for the second spacewalk of the mission were both accomplished. We spoke with Mission Operations Manager Keith Wallace just after he stepped off console to get his views on both the issues his team had to work as well as the significant accomplishments of Flight Day 5.
So today was our second spacewalk day. We call it EVA2, the extravehicular activity. It was a challenging day. We started off on a euphoric note. That first RC, the first two gyros, they went in no problem, and we're really happy about it. Everything was going great. And then the challenges started. It was tough. The crew tried to get it in. They couldn't get in. They tried different methods. It was impressive how well they were working getting this done, but it still wasn't happening. And there was a sense of concern in the stock. You definitely have some nervousness. However, having said that, we also know how well this crew does. Well, look at the great job they did yesterday with wide field camera. So yeah, it was definitely some tough feelings, but we never lost faith that they were going to get it done. And they did, and they absolutely did a fantastic job. We tested it out. We did that aliveness test to make sure everything turns on right, heaters come on, perfect. Everything's looking very, very good with them. And then finally the batteries. So we went on to the battery task, and we actually thought that was going to be a little more challenging. It turned out to be no problem. The crew took care of that. They made it look easy. It worked wonderfully. We've done our aliveness test and our functional test, and those are working great. So our first three batteries are changed out. Everything today, despite the challenges, was a fantastic success. Tomorrow we have a very long day of working on the advanced camera for surveys and CAUS camera. And they did this small get-ahead task, and it was a get-ahead task today where they had to route some cables and connect the cable together to provide power to this new hardware in advanced camera for surveys. And they could access it more easily from the door that they're in today. They did it tomorrow, they'd have to literally bend over backwards to get to that cable. They did it today, and it worked fine. So that's going to save us time tomorrow. And that's important because tomorrow is going to be a really long day. The two activities we have tomorrow, we're going to take out the original corrective optics, which was installed back in 1993, and put in a new spectrograph. When I say a camera or spectrograph, it's not a small camera like you see at a store. It's about the size of a refrigerator, and the astronauts are going to change that out. So they're going to take out this old corrective optics, put in this new cosmic origin spectrograph. Then the real challenging task happens afterwards. We have one of our most famous cameras, our advanced camera for surveys, which really takes some of the best pictures you've seen so far. Well, unfortunately, about 2 years ago, this camera failed. It had an electrical problem on board. And this is a camera we just installed in 2002. Well, the astronauts are actually going in and repairing it. So they're going to go inside and get into the guts of it, and they're going to take out some of the boards that aren't working and put in new ones. And after that, they're going to button it all up again, and it should work fine. It's going to take a little longer to do on this day, and we've looked, and if everything is going according to schedule, it'll be a longer spacewalk than what we do on a normal basis. And that's one of the reasons for that get-ahead task today. Anything we can do ahead of time to make it easier. In fact, those latch over center kits, those door latches we put on the first day, those were a get-ahead task for this also. So anything we can do, we try to get this done ahead of time so that tomorrow we hope everything will go as smoothly as possible.
Saturday's spacewalk will see the installation of COS with the Cosmic Origin Spectrograph, the second new science instrument being added to Hubble during STS-125.
COS is the most sensitive spectroscope that we have ever flown in space. Spectroscopes or spectrographs are so important for research. They produce ugly pictures. But they are the nuts and bolts of physical science. They put the physics in astrophysics. COS was conceived in the mid-1990s by Dr. Jim Green and his colleagues at the University of Colorado, primarily to study the cosmic web, which is made up of the largest scale structures of matter in the entire universe. If you want to know what something is made of, how hot it is, how dense it is, how how fast it's moving in space, how fast it's rotating, for example. A spectrograph will give you all that information. With COS, we can acquire information like that farther out across the universe than we've ever been able to do before.
Spectroscopy is taking light from an object and breaking it up into the different colors that that light consists of. Each of the elements, each of the chemical elements has characteristic wavelengths, characteristic colors at which it emits light when you heat it up or absorbs light. For example, if I have a tube full of hydrogen between me and that light, instead of seeing the normal spectrum of that light when I look at it with the spectrograph, I'll see that spectrum but with some of the light taken away at the wavelengths where hydrogen has its characteristic absorptions. And so by measuring the depth of those notches and the velocities and the width of them and so on, you can infer all kinds of things about the physical state of that cloud. COS has taken a really key part of spectroscopic science and said, how can we do that in the absolutely best, most efficient way? And that is to measure the properties of the material between the galaxies, looking back into the universe. As the galaxies form, there's a lot of material that does not collapse into the galaxies, and there's other material that is ejected from galaxies by supernova explosions and so on. And so that intergalactic gas, the so-called intergalactic medium, carries a lot of information about the history of the universe.
When you couple that story, sort of the global cosmic process of how you form the large-scale structure of how material is distributed in the universe and what role that played in forming new galaxies, and then you use Wide-Field Camera 3 to investigate how did the galaxies themselves change internally with time and over space, looking back through the history of the universe. All that kind of ties together into the full story of where we came from.
It's going into the CoStar slot, and so there is nothing whatsoever lost in doing that because CoStar is not needed anymore. CoStar was put up in the first servicing mission, and it was used to deploy correcting optics in front of some of the first generation instruments, the first generation spectrographs, for example, correcting optics to correct for the spherical aberration that had been inadvertently built into the HST primary mirror. All the more recent instruments include that correction within the new instrument itself. So right now, CoStar doesn't have anything to do. All the other instruments in the so-called axial bays of HST have their own internal correction, and so the CoStar space is freely available, and they'll pull that out at no loss of science to HST whatsoever and replace it with this terrific new spectrograph.
The other major activity during the third spacewalk of the mission is an activity that has never been attempted before, getting access to and making repairs to specific components of a non-working science instrument, in this case, the Advanced Camera for Surveys, or ACS instrument.
We are going to add a shuttle servicing mission to the Hubble Space Telescope to the shuttle's manifest to be flown before it retires.
At about 7:35 Eastern Standard Time, Hubble entered into inertial hold safe modes. We noticed spikes on the structure current and the main bus current. We believe that this is indicative of a short circuit that occurred in the Advanced Camera for Surveys.
ACS was inserted on Hubble in 2002. Before it died, it was the most heavily used instrument on Hubble. ACS was our best survey camera, so it was able to, for example, map the distribution of dark matter in space. No one had ever done that before. ACS was critical to our study of dark energy, surveying the the galaxies out across space for exploding stars, supernovae, that would indicate how far away those galaxies were and how fast they're moving away from us.
So we were pretty far along on STIS, and then ACS failed, and that was really late in the game.
What failed is a power supply, and in fact in the ACS there were two power supplies, one redundant set of power supplies, so one of them failed and they switched to the other side, and the other one then failed. So there was not much time, but it was decided to see if we could come up with a fix for it.
We leveraged what we learned on the STIS job. How to get to those components, how to remove large numbers of fasteners with fastener capture plates, how to build special tools for the astronauts to do the job.
Just getting the thing to work in this amount of time has been difficult. We're running probably 2 to 3 times faster than a typical program, getting things from concept to design to actual cutting metal and building things.
It has become one of the fortes of our program that our people are really, really good at rapid development.
Removing the card, the cards that we're taking out are very similar to the card that's being removed in the STIS repair. And in the STIS repair, they are going into where the power supply is, because that was also a power supply failure. So they're taking off 111 screws for STIS, and it's 32 for us.
We had learned an awful lot on STIS. We knew how to get to these places. We knew how to pull covers off. We knew how to pull cards out. Now the problem was, could we do it where ACS components were located?
These instruments were never designed to be opened up by astronauts in space, and certainly not by astronauts in space working in big, bulky spacesuits.
So we needed to make sure that what we were doing was something that could be done by an astronaut in zero gravity with this big puffy suit around them, constraining their movements. And not only that, but it's inside what's called the aft shroud of the Hubble Space Telescope. So the space is kind of confined. They have these doors that they open up and can get in. But where we're actually going in is they kind of have to reach around some of the stuff and not work right in front of their faces. The primary detector of the ACS, what's known as the wide field channel, is a CCD, just like in your digital camera, only it's 16 megapixels. So there's a box that controls that, the CEB, and that's what we're taking out. And it's probably fine. It actually is probably still working, but that's the easiest way to get in and get new power into the system. We had to design a plate that goes on top of where we're taking off the screws, sort of clips on there, and has little holes in them for the screwdriver to go through, the bit, and those are too small for the screws to pass through. And that was designed for the STIS repair, and they had a very large one with lots of different types of screws, and we were fortunate that we are, in the end, only taking out one size of screw. We're going in through the top of this box, and there are 4 circuit cards in there. We'll pull those out, and that leaves us a hole with connectors at the bottom. And those connectors are what connect to the detector and what used to supply power to it. And then we'll have a little cartridge with 4 new cards in it that will slide into that space. And that will allow us to make connections there with the new cards. But also the power now will come in from the outside through our external power supply instead of coming in from the bottom.
It's particularly important to repair ACS because it, together with the new camera, the Wide Field Camera 3, make a complementary set. They have a full set of capabilities that astronomers need in cameras operating together. It's very clear that after the servicing mission is over, astronomers will be using this combination of Wide Field Camera 3 and Advanced Camera for surveys about 2/3 of the time.
So recapping the activities for Flight Day 5, the spacewalk completed by Mike Massimino and Mike Good was the second of the flight and the 20th in the history of Hubble servicing missions. On deck for tomorrow, installing a new instrument that will help put more muscle in the physics of astrophysics and an unprecedented on-orbit repair. We will now return to Mission Control in Houston for continuing NASA television coverage of the flight of Atlantis on the STS-125 mission. Up next on NASA TV will be the first airing of the Flight Day 5 highlights video package.